Hello, everyone, and welcome back. Before we go on, let's just say thanks to Container Solutions for organizing this event, and thank you for our sponsors, Container Solutions, Equinix, Cycloid, Giant Swarm, Instana, and Kenvote for sponsoring the event. Right now, we're going to hear from Eric. Eric he does advocacy at SNCC, and he's going to tell us about a massacre. I'm not going to spoil it. Eric, there you go.
Thank you so much. Yes, welcome to the Texas Container Massacre. Why Texas? Because I live in Texas. That's the only reason. Today we'll be talking terrifying tales of lifting, shifting, and being buried by legacy apps that you've tried to drop right into containers. As she said, I'm Eric Smalling. I'm a developer advocate at SNCC, and I've been doing container work for quite a few years. That's my info, Eric Smalling, basically at any social media. You can always find me. Let's get going. So tonight's tales, we'll be touching on a couple in depth, and then I'll try to hit a few if I've got time at the end. First, we'll talk about a serial murderer that's going after Java VMs, stumping operations officials at a pharmaceutical I worked at once. Next, we'll get into some legacy licensing curses and what they can do to you if you're not aware of what happens in the containers. And then we've got a few quick hits, like I said, we'll try to get to. So first, serial JVM murders. So years ago, I was consulting at a pharmaceutical that had been had a legacy Java VM app. And let's just imagine that this is Tomcat based. I believe it was actually, but it was based on the JVM. It was a vendor-based application. And it was running in pet machines. These machines have been around forever. They had scripts and manual processes to keep them alive. And these Tomcat-based vendor application servers, they were big boys. It was more like that kind of a cat right there. I believe they had 32 gigabyte heap each. And they, managing this and trying to keep those pet servers up to date was really a problem. And one of their engineers or architects had gone to a conference and he learned about containers, and containers are the future, right? Of course they are. And so what we're going to do is we're just going to take these big, giant 32 gig heap JVM based app servers, we're going to run them in containers. And that way we can make the underlying servers completely generic. They're fungible. We can create them, we can move them around, and it'll just simplify our lives. Well, that's the plan. And it's not a bad plan. I mean, you can do that. But unfortunately, when I showed up, it wasn't that panacea. It was more like this. The containers just, they weren't doing well. And what we were seeing was the containers were getting killed. The orchestrator was killing them seemingly randomly, but usually under load. So every once in a while, the container would just die and get rescheduled. And they weren't sure why, what was going on. And so the first thing we did was I said, let's look at the evidence. What are we seeing? They had a good setup of monitoring the applications themselves. They had a application performance monitor that was pulling all of the stats the JVM was spitting out. And what we're seeing is right before container death, we were seeing a large allocation of memory happening. And we're like, okay, or at least a large string of allocations of memory that had been happening right before they died. And luckily, these guys have been running this JVM-based application for a long time. They've done a lot of tuning. They had their GC logs set up correctly, and they were spitting them out. And we could see tenured or heap space getting near 100% right around the time they died. So more evidence. And if you looked at the standard out from that JVM, you could see out of memory errors occasionally and other interesting crash messages, panics. Just the JVM basically was having the rug pulled out from under it. So let me take a step back for a second, because I know not everybody watching is a Java expert, and let's talk a little bit about how the JVM deals with heap memory. So I'm going to go to the whiteboard here real quick, and hopefully we'll switch over here. Let me erase some of this. The way Java basically works, I'm not going to go into details, but is when you're allocating objects, it puts it on what they call a young or an Eden, or depending on what version of the JVM. This is back in JVM 8 days, and they had to stay on this old version because of the support of the vendor. It puts the objects into that, and it does what they call young garbage collect. So if this is memory and this is time, and you see the spiky behavior happening on your used memory, that's the young GCs happening. So the Java virtual machine is saying, hey, every so often, what have you allocated that I can get back? Because we don't want to have it out there. It's no longer being used. Let's reclaim that memory. Well, that works great until a certain point, and there's a maximum heap space. Now, they had set it, as I said, at about 32 gigs. So we'll just say that's 32. Well, as you get closer and closer to that, something's going to happen. You're going to run out of memory because there are objects that you've been keeping, and they might still be needed, they might not be. Well, the way that the garbage collector works is that every time that young GC happens, if a bunch of objects haven't been allocated or haven't been garbage collected after a while, it will move them into a tenured or old space. This usage is the sum of the new and the old space. Well, eventually, we get up to here, and it has to go through the old space and say, okay, look, those objects that I couldn't really determine before if we needed them long-term or not, I got to do that now. And it does what we call a full GC, where it stops the threads and it sweeps through all those objects, looking to see which ones of these can I get rid of. And they call this a mark sweeps because it marks all the ones for deletion. It says, okay, all of these objects actually were deallocated, and I can now destroy them and get the memory back. So you'd see the memory graph would do something like this, and it would spike and spike. And under normal behavior, that's how it works. Well, what we were seeing is right here in time is where the death was happening. So I asked them, and we can go back to the slides now. Are you setting C group limits? Are you setting container limits for memory around these? And they said, oh, yes, we are. I was like, oh, that's good. You should do that. That's a good practice. What are you setting them to? Oh, a little bit more than the heap. There's a red flag. We'll get to why in a second. And I said, are these VMs that you're running these on, how much memory do the VMs have? Oh, a little bit more than that to give us overhead for the OS and the orchestrator. I was like, oh, okay, well, we'll have to talk about that. Now, if you look at talks and blogs from Oracle, Red Hat, some other folks that have talked about Java VMs and containers, especially back in the Java 8 days, Java 8 and 7, you realize the sizing of the heap is not what you should use to determine the size of your container or your C group. The JVM and the garbage collectors need a lot more space. And in fact, unless you've profiled your app very detailed under load and figured out exactly how much to give it, they recommend 2x, which blew me away the first time I heard it. That's a lot of RAM. In case I'm telling them, yeah, you guys, you're going to need 64 gig C group space for this. And they bug-eyed, and I said, or you can drop your heap to 16, and then you'd be within the 2x. And the reason is that, when that big full GC, worst case scenario, when that happens, there's overhead that the JVM needs to be able to do that. And as soon as that JVM process tries to allocate 1 byte over that container limit, that C group, the kernel comes in and says, dead. I'm going to kill you process because you asked for more than you were supposed to ask for. Now, to compound this application, that 32 gig of space, they were caching a ton of things because they wanted to be fast. They wanted those things to come up on the web app quickly. And that causes a slow startup because they didn't want anyone using an instance of the app until that cache was full. So the orchestrator would kill the process because it asked for too much RAM, and it would reschedule a new one. And that takes 10 to 15 minutes to come up, literally. And if another one happened to have that happen, now you get 2 of them starting up, and you've got that thundering herd problem attacking your database. So what we recommended was increase your C groups or limit your heap, deal with the slow startup, and remember that the JRE doesn't understand C group limits. It doesn't, at least in this version of Java, it didn't really know that there wasn't that much RAM to use. So it's just going to keep going and going, and so, oh, we're out. So that's one story. The next one I'm going to talk about is legacy licensing schemes. Now, again, we're talking lift and shift. So these are older apps usually. And many of these apps were written in a time before containers were popular. And a lot of the vendor-based licensed things that you deal with don't really understand how things work inside containerized processes. So this company I was at, they had a pretty basic setup. It was a back tier that had some JEE apps, database maybe, running on the back tier servers. We had a front tier that had a Spring app with maybe an Nginx in front of it, and some dev servers. And these had like CI, Selenium grids, things like that. And they had one of those application monitoring tools from a vendor. It was a great tool. It is a great tool. I'm not going to say the vendor, but the way that vendor licensed though was by how many hosts you ran the agent on. And in this contrived example on my slide, I've only got 3 with 6 licenses. So you just would install your agent on each box, and that would use up a license slot. And then your graphs and pretty charts and everything that you have on your dashboard would say, oh, for machine XYZ ABC, that's a back-end machine and all the things that are running on it. And then for the second machine, that's a front-end machine, the front-end apps on it, and so forth. Well, architect at this shop says, hey, I just got back from a conference and containers are the future. They are. Containers are great. What we're going to do is I don't want to manage all these front end, back end, whatever servers. I want to have a generic mesh of servers, and I'm going to let Kubernetes or whatever orchestrator just manage it for me. We're going to put everything in a container. We're going to lift and shift. Sounds good. Well, they said, that way, when the rescheduling happens and things move around, I don't have to worry about where things are running. That's great. Well, one of the problems with that, though, is that, well, we used to run the monitoring agent on each host. But when we try to do that now, the monitoring system says, oh, well, today we had this kind of application running, and now we have that kind of application running. And all of the setup they had for their monitoring wasn't working right for them anymore because the way they were graphing everything. So they said, you know what, we're going to put the agents in the container images so that we can have them specified with arguments to say this is a front end process and this is a back end process and so forth. Great, sounds great. When you run a process in a container, and especially these agents who use host name as figuring out how many hosts you're running on, and each host name equals 1 license, you run out after 6, in this case, 6 are deployed. And that meant for them that all the other ones aren't being monitored anymore. That obviously they caught this in dev. It's great, didn't go to production with it. But the failing here was they didn't talk to the vendor. They didn't go talk to the monitoring vendor. That vendor has a new version, and that is container aware and different patterns for installing these agents. So if you are using legacy tools, make sure that they work in containers, make sure they're supported in containers, and that their licensing scheme works with them. Otherwise, you could run into this problem, and they had to go back and pay for an upgrade that they didn't anticipate. So bring vendors to the table when you're moving into containers. A second licensing problem that was a little more insidious. This is another case of an e-commerce vendor-based application, happened to be a JVM-based. And they were running them on servers, or I don't remember if they're VMs or bare metal, honestly, but they were 8-core servers, was basically the size that they wanted to use because of the mix that they would get from their ops team. And they knew that these JVM-based e-commerce apps never needed more than about 2 CPUs each. They horizontally scaled this so that the load never went more than 2 CPUs each. So they're wasting a lot of processing power on each one of these, and that's money. So they said, hey, I went to a conference and I heard about containers. Actually, I skipped forward. So each of these processes sees 8 CPUs, and that's how this tool is licensed. Sorry, I skipped that part. The licensing was CPU based. So we have 24 CPUs here. We're not using all of those. We're wasting our money on that too. Containers are the future, right? So we're going to put everything in containers. It allows us to genericize things, and we're going to use these handy CPU limits to cordon off 2 CPUs per container. So we can run up to 3 of them on a box, and we'll leave 2 for overhead. That sounds plausible, seems like a good idea. That should equal only 6 CPUs per physical. So we got 18 CPUs. We're saving money on licensing, or we can run more now. You know, Eric, the developer, can run his own copy now, and we have a license for it. We're not going to have to worry about running into license issues. Well, it's not how it works. Again, I told you that this is legacy tools, legacy JVMs. This was, again, a Java 7 or 8, I think it was 8 based tool. When the JVM looks at, when it's coded to the APIs back then and looks to see how many CPUs a server has that it's running on, it sees the host. It doesn't see the C group limit unless you explicitly know how to go look for that. So by default, these things came up and each one of them saw all 8 CPUs. So there's the licensing count came out to 72 total across this contrived synthetic example. But they hit their limit and they were out of compliance immediately as soon as they started trying to run this way. So same thing, make sure your vendor offers a version, and sure enough, this vendor did. It only costs 6 figures plus, but make sure they're when you're making your decision about this, make sure you're thinking about licensing. So how much time? We've got about, I'm ripping through this. Good, we've got some time. Let's take a few quick hit ones. I don't have specific slides for these, but we'll just talk about them quickly. The story of the horrifying experiments they were doing to defenseless containers live in production. Don't do this. Actually, this wasn't production. This was a POC. I was at a financial institution. They were doing a POC on a container cluster, and this is an old company. Financial institution that's been around for over a century. They have very tried and true and strict security team processes and procedures, which is good. That means if you're using that financial institution for your retirement fund or your savings account, that they're protecting your money. That's a good sign. However, when looking at new tools like Kubernetes, I mean, this was a little bit earlier, so it could have been Swarm or Mesos, it didn't matter. But you're looking at new technologies that have new ways of doing business, you need to make sure you bring security to the table along with everybody else so that you don't get down the road and run into problems because they weren't aware of what you're doing. Well, what we were doing was they had a vendor-based middleware tier that was sizable. I'm not going to say the vendor. What they wanted to do, the legacy way they used this thing was they would deploy these across their VMs and then they would manually own them in their pets, right? They would take care of them. They would patch them by SSHing into the machine and per the vendor's instructions, running a patch that would basically take that one node out into maintenance, apply the patch, and then bring it back in. And then they just do that across the cluster. They also would deploy the application using this middleware APIs, right? It had a application deployment functionality. And we had worked through this POC to say, okay, let's stop using that. Let's take the vendor image, because they did provide one, and apply the application on top of that, and we'll use the orchestrator to handle orchestrating and running the cluster. And we did the work needed to do that, and they're happy. But then all of a sudden, on I think it was a Friday morning, afternoon, we get this frantic call, hey, security is going to shut our servers down. We're like, what are you talking about? So, well, they have this thing baked into the host OS image, the security scanner, that has found that the patches we applied to those images didn't take. So what the heck? So we get on the machine and we look around, and sure enough, what it was catching was in the Docker container layer file system, the cache for the images that are on each host. In those layers for the original base, there were some text that their regex parsers were catching for the older versions of this middleware software or libraries that it used. Even though we had patched it in a layer on top, and those changes were eclipsed out in the final file system in the container, didn't matter to the security. They weren't talking. They were saying, this must not happen. You cannot have this. And when we went back, we satisfied them. We said, hey, hold off for a week. Let us work on this. We went back to the vendor to say, hey, can we do a multi-stage build or something where we wipe out that stuff completely from the final image? And they, no, we won't support it if you do that. So this was kind of a mess. This was a bit of a cluster. So again, this is just another case of, if you're going to do DevSecOps, if you're going to do DevOps, don't forget the sec. Make sure security is at the table, because really the long-term fix for this would be, we just need to change the way we look at this and stop scanning the way we're scanning, or we need to work with our vendor to get a newer version that handles this. I don't know if the vendor ever fixed this. This POC actually failed. We were not able to get them to the point where they could move forward with a production deployment. But the stakeholders at this customer were very happy. They intended on shining a light on this kind of a problem, and they were happy that we came in and helped them find that. So that was interesting. Let's see, another quick hit. What do we got? We've got 10 minutes, cool. Cyborg containers. So I was brand new at my consulting job at the company I was at, dropped in the first customer I was dealing with, and I knew containers. I've been using containers since like .6. Before there was a Docker Compose, before there were any orchestrators. I know containers, I know how containers work. I drop into my first enterprise customer, and they're asking me questions about, you know what, we're running system D in our container with SSHD, and we're dealing with X, Y, and Z problem. And I think the team that was doing this might be watching this right now. So hi guys, I love you. And ladies, sorry, excuse me. But they had a very unique problem, I'll give them that. They had a very unique situation where they actually needed users to be able to SSH into them, make some tweaks, and then they were actually doing a old school Docker commit, taking that freeze dried image into a registry and then taking it over to the next environment to run with the tools that the user had done. Really crazy stuff. They had a whole application around this to do it. They may still be using it, and they were willing to put in the time to do this. So more power to them. However, this is, as you probably learned in your Docker 101 classes or Container 101 classes, containers are not VMs. If you treat them like VMs, you will have to do a ton of work to manage them. They're not meant to be long-running thing. They're supposed to be ephemeral tools. Now, this customer actually was doing some data science work that there was another package that somebody else offered that ran on top of Kubernetes and provided similar functionality. I believe they were moving to that. Do that research up front and find that. It could have been that that tool wasn't available when they started this work, whatever. They actually did some amazing work around this. That's a hairball that you don't want to deal with. Last one. Look at this. I've got tons of time ripping through this. Hopefully I'm not rambling or sounding too fast. Quick hits, number 3, the unintended consequences of overexposure. This wasn't a customer I actually worked on, but this was another team at my company worked with, and I was unaware of this, but back in January 2019, Project Calico, which is the CNI plugin that a lot of people use for Kubernetes. It's one of my favorite plugins. It's a great CNI. I'm not bashing Calico or the project in any way. I love that plugin. They added something in January. I forget the version number, but the links are there, and we'll share these slides afterwards, I'm sure. But it allows you to advertise the service IP CIDR, or whatever range you want from your service IPs, outside of your cluster onto a BGP router external. And the idea being, you don't need a load. If you don't have a load balancer, don't worry about it. You can do this. And when you're on premise, having a load balancer that's automatic is not given, right? You could run MetalLB. If you're a VMware shop, you could run the NSX stuff, but it's not given that you'll have a load balancer when you're not in a cloud environment. So no problem. Advertise your service CIDRs on your routers. And as long as your host name is resolved, it'll just automatically hit into the host, and as those endpoints move around, Calico will keep that up to date. Sounds neat. Sounds like a good science project. However, if you're going to do this, please read their blog, read their tutorial on what it's doing, and understand the risks you're doing when you go into this. Because what you're doing is you could be, if you do it poorly, exposing your entire service CIDR of services you didn't mean to expose to the outside world, and any nefarious person who is on your network and wants to start pinging at it is going to find services that might not necessarily need to be exposed outside your network. They shouldn't be. There is a way to do this with external IP, and that is most likely the best way to do this. But read up on it before you attack this, because you could be overexposing stuff that really you didn't want to expose. With that, I'm glad that I have a couple minutes left. Again, there's my name and contact. This was a hard talk to do, to follow up Chris Nova's talk. She's a developer advocate, and I'm a brand new developer advocate. I just started this position a month ago, and I came from a consulting background and a developer background before that. I say that because if you're watching me recorded, or even now, if you're watching me live, and you haven't seen her talk, go watch it right now. Pause, don't do anything else. It's worth watching. It's the best talk I've seen this year. So I want to thank Chris Nova. Thank you very much. I don't know you, but we have a lot of mutual friends, and I hear very highly of you. And thank you so much for that talk. And with that awkward end, this mad scientist is done.
Thank you so much, Eric. This is a lot of fun. It's my favorite thing to watch talks like this, because it's like, you know, when you watch videos of, you know, car crashes, that kind of stuff, it's a bit morbid, but it's so much fun.
Not fun while you're in it, but
sorry?
It's not fun while you're in the middle of it, but it's a great learning experience.
Well, I'm just hearing about it, so I'm all good. I don't see any questions in the chat. Let me just double check here. We do have a couple minutes. If anyone wants to ask a question in a hurry, this is your moment. If not, you can reach out to Eric afterwards. Welcome to developer advocacy, Eric. That's also my job. So yeah, that's what we do. I'm also looking forward to watching Chris's talk. I missed it earlier. Maybe I'll watch it now. Anyway, moving on from here, if we don't get any questions in the next few seconds, we're going to go watch Joe Beta's talk in track 1. And I believe this closes track 2 in this conference. So thanks, everyone, for coming. I don't think we're going to get any questions. It's pretty quiet today. Thanks again, Eric. This was a super fun talk. And that's it, everyone. See y'all in track 1 in a few minutes.
Thank you.